Now, I would like to invite on stage Mr. J. Thakur from RAMKY Group and start with his presentation. Thank you.
Everyone, I'm Janendra Singh Thakur from RAMKY Group. Now we have rebranded ourselves as Re-Sustainability Limited. So Re-Sustainability Limited is involved in a waste management company. We are actually a biggest waste management company in India. So whatever the waste, you take the name and we are processing that waste. It may be the hazardous waste, it may be the industrial waste, it may be the MSW waste, it may be the biomedical waste or the electronic waste. All we are recycling. The re-sustainability, its name is the re means the recycle, reuse, infinite time. So mainly I am involved in the control and instrumentation of the waste to energy plant. So what is the waste to energy plant? We are taking the municipal solid waste, is coming to our dump yard. We are processing it and we are generating the RDF as well as the organic waste, we are generating the compost. And from this RDF, we are taking it to our waste to energy plant. And after incinerating it, we are generating the steam and power. So on the lighter note, what we are discussing, the APL, Advanced Physical Layer, and which is given by the subcon to us. So here we are having the name are there, immersion. We are having the field instruments from the immersion. We are having the Yokogawa same systems. We are having the ABB motors and VFDs. We are having the Siemens PLC as well as the relays, Schneider electrical components, and all these are communicating or are connected with our DCS that is provided by the subcon. So I will discuss about the subcon Ethernet APL introduction and the subcon APL products and solutions. So roadmap for the Ethernet to field, how we came to this APL solution. So first in 1999, subcon uses the Profibus field bus technology. Then in 2005, subcon hosted Ethernet of the plant automation or the E to field concept. In 2007, subcon becomes the first field bus international standard and independent IP rights in the China. In 2011, subcon foundation field bus control system came. It is the third manufacturer in the world pass 61B system certification. In 2019, they came with the two-wire Ethernet standard release, and 2021, they came with the APL standard, and in 2022, they came with the IOMC. So what is the challenges I am facing? The basic thing is that in the waste to energy plant, the waste to energy plant is totally depends upon the heterogeneous fuel. Means we can't say what will come as a fuel. As municipal solid waste, it is a heterogeneous fuel and the low caloric fuel. And burning the low caloric fuel and getting the steam and the generation. So what is the biggest capacity of the plant is in India currently is a 24 megawatt. That is the largest waste to energy plant we are having in the Delhi, Bhawana sector, Bhawana dump yard. And then we are having in Hyderabad, that is the South India's first and largest waste to energy, is a 24 megawatt plant. We are coming with the, again, more 4 to 5 waste to energy plants. 2 are under the commissioning stage. In this waste to energy plant, what is the basic problem is that when we are storing the waste, there is a leachate is coming. That is, leachate means the single drop of water which is coming outside the waste is called as a leachate. And it is in the -9 meter of the pit. And again, we have to control the pollution which is coming outside the chimney. So all the parameters is monitored by the CPCB and the Pollution Control Board. For that, we are having the FGCS system, that is the flue gas cleaning system. Means instrumentation or control and instrumentation technician or engineer has to work from -9 meter to the 45 meter of the chimney. Everywhere there is a instruments and all the parameter is very important. As this technology is coming to India, we are having only 5 to 7 plants in India which is working properly in the waste to energy sector. And what happens? Still we don't have the data because every plant will work differently. Why? Because every city's waste characterization is different. If the urbanization is more, waste quality will be good. If it is villages or the tier 2, tier 3 city, organic waste will be more. So to control the parameter, to get the data, to analyze the data, and to apply this data in the next engineering stage. Because I am looking after the control and instrumentation engineering as well as the operation and maintenance of the plant. All the plants, whatever the running in the by the RAMKY group. So this data characterization, collecting the data, analyzing it, and how these plants are behaving and what care we have to take in the future projects, that we are generally thinking. So why the wide plant equipment distribution, outdoor applications, no on-site power supplies, because at -9 meter it is very difficult to work, as well as there are the lot of gases that we have to measure, means all the analyzer at that meter, -9 meter, -7 meter, -6 meter at the pit, because when I am storing the waste for the 15 days, it will generate the gases. And to measure these gases, I required majorly the analyzers. Then challenges what we are facing, this is the long distance communication is there, and the same cable we are using for the transmitting the data as well as the supply. Hazardous zone applications, huge data transfer, and multiple subsystem compatibility with the DCS. So because operator should be always active, due to this intrinsically hazardous environment, we have to be very careful while running the plant. So why this APL advanced physical layer system we are utilizing now? It is a two-wire intrinsically safe Ethernet physical layer designed for the process industries. IEEE 802 standard compliance, maximum transmission rate, what we are getting is a 10 Mbps, maximum distance we can cover up to the 1000 meter, power and communication on the two-wire, rugged for the process plant, field applications, operational in the hazardous areas, and trunk and spur network architecture, and the screw type connectors we are using, and it is very easy for installation as well as the maintenance. Now this is the APL technology, advanced physical layer technology. We have the facility Ethernet, we are having the power switch, then we have the trunk which we can run up to the 1000 meter, having the speed of 10 Mbps, and maximum distance we can cover is a 1000 meter. Installation area is the zone 2. Then we are having the field switch at the end, the spur network. Spur network we can run up to the 200 meter. Its speed is also 10 Mbps and maximum range is 200 meter. And installation area is zone 1 and zone 2. These are the cable and connection. So this is the field bus type A cable, same as the foundation field bus and the Profibus PA. Shielded and twisted pair cables we are using, and screw type or the clamp type connector. So these are the three cables. You can see one cable is the APL signal plus, second is the APL signal minus, and third one we are using as a shield. So this is the roadmap when they have introduced us, because from our first plant, what we came with the waste to energy at Delhi, Subcon is associated with us. From the first plant to the now we are commissioning the 5th plant. So Subcon is associated with us, and this is their product roadmap. In 2021, they come with the APL coupler and the APL wireless gateway. In 2022, APL power switch, APL field switch, smart EIO, the wireless gateway, APL pressure transmitter, APL temperature front end. And in 2023, they again came with the modified version of the APL coupler, APL power switch, APL smart EIO, and APL field switches version 2.0. Again, they are providing us the APL electromagnetic flow meter as well as the positioner. This is the APL advanced industrial network solution. Now see, the basic, if the safe area zone, you will see this is the normal DCS network. We are having the server, engineering station, operator station, management station, and for the other cloud applications, we are having the software. Then we are having the controller. After that, if you see, there is a APL, there are the two scenarios. You can use full APL deployment, or second scenario is that with the APL, you can use our general instruments. So first APL, in the full scenario, you can use APL power switches, and we can run the trunk for the 1000 meter. And then we are having the APL field switch and APL instruments. So this is the scenario 1, where we can use the total APL deployment. In the second case, we are using the optical fiber. In our plant, we are using the optical fiber, then we are having the APL power switches, and then there is the APL smart EIO. In this APL smart EIO, you can connect all the instruments which are currently available in your plant. Second one is the APL wireless gateway, where you can connect the wireless instruments. Then you can connect the field bus instruments also to directly to through the APL power switch. Now they are having the different topologies, redundant as well as the non-redundant. So that I will show you. So all the three types of topology you can use for communicating for the field instruments. The first one is APL network topology, the star that is having the redundant and redundant system. Then we are having the loop and the bus. We are using the star because we require the redundant systems. Again, next slide I will show. This is the intelligent network diagnostic, what they are doing. In this, we are having the DCS controller, power switch, APL field switch, and instrument. So there is a auto detection system, that is the system is offline or online, is auto load drivers and the auto assign address. If you are changing anything, it will assign the address automatically. Auto generate the system network topology for visual network management and diagnosis on the network devices and the link qualities. So they are having the software from where we can know everything, where is the fault. Again, there is a end-to-end device management, means subcon asset device management support us for configuration, then commission, maintenance, calibration, forecast and diagnostic of the intelligent instrument, and automatic document management. This is the unified architecture, just the same thing. It is the simplified one. What you have, the operation station, one DCS cabinet, and from that cabinet you can connect the wireless instrument or the APL, all the APL instruments, and the smart EIO, you can connect the general instruments what you are having currently in your plant. So basic thing is that why we are going towards the APL. The main thing is that the money, means we have to reduce the CapEx reduction. When we are introducing this system during the project stage, what happens, the comparison is there, and we are considering the 10,000 IO points for on the project scale. Currently, waste to energy, we are utilizing 8,000 to 8,500 IOs. So for simple calculations, we are considering the 10,000 IOs. So what is there is that in traditional DCS, you are having the 60 to 70 cabinets in the main central control room. From that central control room, again you have to run the cable up to into the field. Then you are having the junction boxes. From the junction boxes, then again to all the instruments, you have to run the cables. So in the second case, the distributed deployment, you are having the 5 to 6 cabinet in the central control room. Then you are having the DCS panels at the different location of the plant. And from there, we have to lay the optical cable, and then we have to lay the individual cables to the field instruments. But when we are coming with the APL distributed deployment, we are having only the 5 cabinets in our central control room. Then the optical cable or the trunk cable you can lay. And from APL power switch, we can lay up to the 100 meter we can go, and we can connect through the smart EIO. So it is the high efficient project delivery is there, and as well as you can reduce the cable cost much more. These are the system components of the APL, that is the advanced physical layer. First one is the DCS with the controller. Then we are having the APL coupler and the APL trunk up to the 1000 meter and the 10 Mbps power. You can connect the APL field switches as well as the APL wireless gateway. Again, through the APL, if you are using the optical fiber, you can connect the APL power switch, and through this, you can connect through smart EIO, you can connect your general instrument, and or you can connect the APL instrument, which is APL spur, we can run up to the 200 meters. So this is the simplest network we are having in our plant. So this is the APL power switch. The APL coupler, it is the hardware, it can connect the one APL trunk. It is used in the intrinsically safe environment hazardous area classification is EXEC, IIC T4GC. 8 APL trunk you can connect to the 8-port APL power switch. This is the 12-port APL field switch. In its speed is also 10 Mbps and 1000 meter. You can connect the spur, which is having the speed of 10 Mbps and the 200 meter of the length. And it is also used in the hazardous area classification, as well as the protection they have provided is a IP66. This is the APL smart EIO. In the APL Smart EIO, you can connect any type of AI, AO, DI, DO. So that is the simplest one. You can put it into the site and connect all the instrument to the Smart EIO and get communicated with the DCS. So this is the APL wireless gateway. So all the wireless instruments we are connecting through the APL wireless gateway. Now we are having the APL instruments, that is the APL pressure transmitter, APL intelligent temperature front end. Basically what happens, this APL intelligent temperature front end has saved a lot of cable for us. Generally what happens in waste to energy plant, basic thing is that how much temperature measurement. In the boiler, generally the waste to energy boilers are the 4-pass boilers, not like a coal-based power plant we are having the single and second pass. We are having the 4 passes. And all these 4 passes, a single boiler is having near about 30 thermocouples at different locations to measure the temperature. Now I have to put the thermocouple cable up to the JB. From that JB, again I have to take all this thermocouple cable up to the card. Now with this Smart EIO, what we are doing, we are connecting all these thermocouples to the Smart EIO, the intelligent temperature front-end model. And from here, we are taking directly the normal cable communication to our DCS. So that is saving us the lot of cables of the thermocouple, which are costly also. So these are the simple solutions they are given in terms of the DCS, as well as in terms of communication, as well as in terms of the instruments also. So these are the development and progresses of the SUBCON. Now, as an end user, the Ethernet APL is provided as a secure, high-speed power Ethernet networking solutions. As well as for the further project, it allows for the simplified project infrastructure, fast commissioning. Obviously, the money is getting saved, and provide the ultimate flexibility with the support for the process automation communication protocol. So this is what the SUBCON has provided us we are having the long-term collaboration with the SUBCON. So they have provided us a good solutions, and it has saved our project costs also.